Hi, my name is Phil from Icam Technologies. This presentation will provide an overview about Icam and its new adaptive post-processing technology, the evolution of machine simulation. The Icam legacy. Over 4 decades of consistent leadership in the post-processing and NC manufacturing software industry. Relentless R&D resulting in continual product improvement and innovation. Unparalleled multi-access specialization. Multiple CAM solution expertise. Enabling customers to remain competitive by production cost reduction, NC machining productivity gains, product quality improvements. Icam has a global presence, supporting world-class manufacturers. You're in good company. Icam has a renowned customer base including Airbus, Boeing, Ferrari, and many more. What is adaptive post-processing? Adaptive post-processing is the full integration of post-processing, machine tool simulation, and optimization into a single, unified, concurrent process. Do away for good with older, less efficient, and less accurate methodologies that perform verification analysis after post-processing, which require multiple manual iterations at the CAM level to produce a part and often falls short of an optimal result. Easily transfer part programs to differing machines. For the first time ever, manufacturers can effortlessly shift their production schedules between various NC machines. This means a unique and 100% kinematically accurate post-processor will adapt the specific G-code for any given part to work with any given NC machine that is capable of producing it. The traditional manufacturing process looks something like this. A CAM program is developed in your CAM system. The CAM system produces an app file that is later translated into G-code by the post-processor. This G-code is verified by a machine tool simulator that produces an error report. This error report is then analyzed and interpreted. The NC programmer then develops a strategy to correct this error in the CAM system. This can go on for several iterations before proper G-code can be created for a CNC machine. Of course, this takes time. With adaptive post-processing, these iterative steps are eliminated, reducing NC programming time by 25 to 35%. All the programmer has to do is create a part program in the CAM system. Icam's adaptive post-processing solution post-processes the app file, simulates the G-code, and optimizes the program in one simple process and in one single step. This video illustrates a typical example of a sequential manufacturing process in which post-processing and machine simulation are executed as 2 consecutive stages. First, the cutter location data generated by the CAM system is posted the traditional way, using a standalone post-processor instead of an adaptive post. For example, here is how an Icam post would run inside CATIA V5, and this is how it would run in NX 8.5. The resulting G-code is then simulated the traditional way, using a passive simulation package such as most software packages on the market today. As you can see, the data generated by a standalone post results in multiple collisions. These collisions occur because a standalone post processor cannot foresee collisions and therefore must resort to the automatic selection of the shorter of two possible solutions. Let us now post again the same cutter location data, this time using an adaptive post. This is the same post as before, but launched with a few additional options: virtual machine simulation and material removal, toolpath optimization, and real-time G-code simulation. As you can see, the post can now preemptively avoid all the collisions by automatically selecting the appropriate kinematic solution. Whenever a collision is foreseen, the post will automatically reposition to the alternative solution to avoid it. During this repositioning, all unnecessary retracts are also minimized in order to optimize the cycle time. This example shows an Icam post-processor running with our virtual machine simulation module, but with no toolpath optimization enabled. Although no hard collisions are detected, you will see that the post is detecting multiple over-travel errors, mostly during these large retract motions programmed in the CAM system. This is a typical situation that arises when a job initially programmed for a large machine, such as the one in our previous example, needs to be executed on another machine with different kinematics and a much smaller travel envelope. We can analyze these over-travel errors by synchronizing the error report with all other windows and the timeline. Multiple errors will occur from this point on. We will now run again the post with virtual machine simulation, but this time we will enable toolpath optimization. The optimization features we will be using here are Smart Path, an option which automatically calculates the shortest collision-free rapid connection within the travel envelope, and Smart Cut, an option which eliminates error cutting moves by converting them to rapid. You can now see the optimized tool motions as they are shown with the dotted line in the graphics area. Notice that no more over-travel errors are reported, and that the tool remains at all times closer to the part. Let's take a look at another example in which a very simple sequence of tool motions is being optimized. We will be running once again a post and virtual machine simulation, first with no optimization, then with different options enabled one by one. The first example shows the non-optimized tool motions. No options are enabled in this dialog that pops up. You can see there is some air cutting here, as well as a rapid collision here. Run this job again, this time enabling the Smart Cut and Smart Path options. These options are enabled directly from the CAM system using a custom post instruction. Note how the tool now plunges closer to the part. Before it had this long air cut approach. Also note how the previous Z-shaped feed move in this area was turned into a direct diagonal move. But most importantly, note that the previous rapid collision has been automatically avoided. Let's run once more the job and enable another one of our optimization features, Smart Feed. Again, this option is enabled via a series of post instructions in the CAM program. Smart Feed adds split points on some cutting moves, applying different feed rates to maintain a constant material removal rate. Optionally, Smart Feed can be set to take into account the machine acceleration and deceleration, the block time, or to limit the number of split points based on different criteria. Why adaptive post-processing? Reduce programming time and machine cycle time. Reduce human programming errors. Improve cutting tool life. Produce better quality parts. Full flexibility to change target machines without recalculating tool paths. Improve customer satisfaction and loyalty. Ability to take on more lucrative jobs. And that concludes our presentation. Thank you for watching. To learn more about adaptive post-processing and how it can help you with your manufacturing process, visit www.icam.com.